Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
The students we talking about the chapters, maybe motion in a plane, motion in a straight line, and laws of motion, right? So about the motion we have studied, and in the laws of motion, what we have studied is nothing but about the dynamics. No, that is nothing but the cause of motion we have studied. That is, force is responsible to move any object. It may be push, it may be pull, or it may be external agency, whatever it may be, we are going to call it. But we can give a formal relation, a proper relation, or in the sense we can give an equation, because F is equal to ma. So before that we didn't know, before the Newton force, they told that there is a force is required to move object from one point to another point. But what is that force? What is its magnitude? What is the direction? All those things. F is equal to ma. In that problem, the formula it came and everything we have studied. And today we are going to move on to the new chapter, that is called work, energy, and power. So what do you mean by work? What do you mean by energy? What do you mean by power? That we are going to talk about. But what actually means meaning of work is? Work is nothing but generally studying, reading. You say it is a work generally. A farmer is working outside. This is called work. And in fact, if you are studying overnight, you will say it is a hard work. Okay. For anything which is displaced or which is some strength is utilized and you are doing activities, you will call it as a work, right? But what physics says, according to the physics, whatever you have thought, is it work or not? That is a question. And what is work in physics? That we are going to study. And what is energy in physics? What is the physics behind the energy? Okay, what is the formulas behind the energy? Where and all we are using it and how we have to use it? Okay, where we are going to put more energy or less energy? These are all things we are going to talk, and as well as the power we are going to talk about. Now, before going to all those things, we again will discuss about the new kind of mathematics. See, in the chapter of motion in the plane, we have studied that vectors will be there, the addition of vector we have studied, that is the different triangle of vector addition, or subtraction of vectors we have studied, that is also addition of negative vector, that is also addition of negative vector. But do we have studied multiplication of vector? Is it? No, we didn't study. See, the multiplication of vector is kind of different. See why? Because vector does not going to obey the normal mathematics, whatever you have to doing with the numbers. 2 into 2 or 4 you will say. But 2i cap into 2i cap is not 4i cap. There something is different. Okay, I cap is unit vector, right? So why it is like that? What it is? That is what we are going to learn before starting or going into deep discussion with this topic. And that I will call it as vector multiplication. Vector multiplication. There are two types of vector multiplication. One is vector multiplication means it is nothing but a product, right? See, addition means we will call it as a sum. Multiplication means we will call it as a product, right? So first we are going to write what is that? Okay, product. So we will call it as a product. There are two types of products are there. Means I will give you a vector, a vector. I will give you a vector, that is b vector. If I multiply a vector and b vector, what I am going to get? Do I get a vector only, or do I get a scalar which is not a vector? Okay, based we have two types, and that is nothing but one is scalar product and the one is vector product. Now, how we will know if two vectors you are going to multiply and you will get a new quantity or product you are going to get, whether it is a vector or whether it is a scalar? That is the question. No. How we are going to divide it as a scalar product and vector product? Suppose I am going to give you P vector and Q vector. I have multiplied both, and this I will got as vector. This I didn't get it as a vector. This I got it as a scalar. Okay. So that I can say if P and multiply Q means I will get a scalar product. Scalar means this becomes a scalar quantity. If A and B, if I multiply and I will get a vector means that I will get a vector quantity. Now, what example I can give you? See, V is equal to F into V is equal or P is equal to P is equal to F into V, right? Okay, that is a vector because momentum is a vector, velocity is a vector. No, force is equal to M into A. Mass times A means this is a vector, means this is also a vector. But certain quantities are there which are not scalar, which are not vector. Okay. Say for example volume. Volume we are considering it as scalar. Why? Because length into breadth into height. No. Okay. Length means in particular direction you can count it. No. But this volume is not having direction. No. What volume I say? What is the direction of volume? Do you ask? No. What is the direction of velocity? That you will ask. Right? That you will ask. Okay, like that. Okay. So we will go into again what actually scalar product is. Later you will understand. Okay. So now first we are going to deal with only scalar. We are going to deal with scalar product. So vector multiplication, there are two types. One is scalar product and vector product, and the scalar product we are going to deal. Now I will give you a simple example. This activity all of you have done, knowingly or unknowingly. This activity you have done. Suppose, have you ever observed a kid is playing with its toy? Now, if any toy is there in this way, what kid is going to do? It will tie a thread, okay, and that kid is going to pull this object. Now where it will move? See, I am going to pull the object in this way, right? So if I write down as a diagram vector, the force will be in this way. But do you think that the toy is moving in this direction? No, it is not moving in this direction. But where it is moving? That actually moving in the horizontal direction. Why? I have applied the force in this way, but the toy is moving in the horizontal direction. Why? Okay. So if I write down in this way, actual force moment is displacement is in x direction. The force will be in this way. That is a vector. Displacement is a vector, right? Displacement is a vector, right? Okay. Why? Because the component theta, some force is acting here. No, all force is not acting. Only some force is acting. Okay, only some force is acting. So we will come to that. Before that, we will write down the vector product as in terms of its component. Don't write down that. That was the example I have given. I am going to explain it. You just write down vector multiplication, two times scalar product and vector product. After that again write down the heading scalar product and after that write down. Okay. So we have bx I cap plus by j cap plus bz k cap. What is the angle between I, J, K? What do you mean by I actually? What do you mean by J actually? What do you mean by K? So I cap will be in this way, J cap will be in this way, and K cap will be in this way. Okay. So this is I, this is J, and this is K. What is the angle between I and J? 90 degree. What is the angle between I and K? 90 degree. What is the angle between J and K? Is 90 degree. All are mutually perpendicular. Let's after that, let's just information I have given. Let's multiply because we are concentrated on multiplication. A cross B which is equal to what you have to do? First you have to write down this ax I cap plus ay j cap plus az k cap. You have to write down. Multiply with bx cap plus by j cap plus bz k cap. Right? Now what I have to do? Ax into bx, ax into by, ax into bz plus ay into bx plus ay into by plus az ay into bz plus az into bx, az into by, az into bz. That you have to write down. So ax into bx means how much? Ax bx. I into I. No, this we are going to call it as dot product. See, when you will say those vectors are the product, see, you will multiply two vectors. Okay, you will multiply two vectors. Now you will get a new vector. Now when you say it is dot product, because scalar product we are going to call it as dot product. If suppose a and multiply, you will get one more. We don't know what quantity we are going to get. If it is not vector, it is a scalar, then we are going to call it as scalar product or dot product. If two vectors are multiplying, new product I am going to get, and that is vector again, I am going to say that this product is nothing but cross product or vector product. Clear? If two vectors you are multiplying, you will get new product, and that product is a vector, means that becomes a vector product or cross product. If two vectors you are multiplying and the new vector you are going to get, that vector is a scalar, means that becomes scalar product or dot product. Now don't write down this. Okay? Don't write down that. This one you have to write down. That you have to write down. Okay? Now see, I and I have multiplied. I and I have multiplied. So I dot I. Isn't it? I dot I. Okay. I dot I means what? That is nothing but scalar product. Generally you can write down A dot B is equal to, after scalar product you write down this. Okay. A dot B is equal to AB cos theta. A dot B is nothing but AB cos theta. What do you mean by scalar product? Scalar product definition is given A dot B which is equal to AB cos theta. Now similarly here Ax I cap is a vector, Bx I cap is a vector, Ax and Bx you multiplied, that is a component, and you got Ax Bi. Now I dot I means what? At the place of I vector is there, I vector is there. At the place of the I vector is there. So it is I into cos theta. Now I means that is unit vector whose magnitude is 1. I means that is unit vector and whose magnitude is 1. So 1 into cos theta. What is the angle between I and I? I is in this direction, another I is also in the same direction. So that becomes 0. The angle between I and J is 90 degree, but angle between I and I is like that it is. So now what is the angle between I dot I? Cos 0. Cos 0 means 1. So nothing to write down. This becomes 1 plus. Okay. So this is the formula. Scalar product means in this way. A dot B which is equal to AB cos theta. Why it is like that? That we will come into again explanation. We will come to that. Now we will do this AX and BY. Okay, right. AX and BY. I dot J you are going to get. I dot J means what? I into J. J also one no. Cos. The angle between I and J is how much? 90 degree. Cos 90 is 0. Means this term is going to become 0. Okay. Next AX and BZ. So AX and BZ I am going to write down. I dot K. I dot K means I and K angle is 90 degree. So it is going to become 0. So similarly if we multiply means you are going to get AX BX AY and BY plus AZ and BZ you are going to get. This is in the analytic form I guess, or this is one form of dot product. This is one form of dot product. So another one is in this way. This is in terms of component it is given is this value you have to use. Okay. Now another form is this, no? That is AB is equal to cos theta. Why it is cross product? Scalar product means AB cos theta. A dot B which is equal to dot product. That is nothing but AB cos theta. Means it is a scalar. It is a scalar. Two vector you multiply but you are going to get scalar. Why it is like that? Why it is AB cos theta? Then we are going to convert that each example what I have given. That is nothing but a kid is applying force in this way by making some angle theta to the displacement, no? But actually what is the displacement? Displacement will be in this direction, no? Displacement vector. Now it is a force vector. Why that is happening so? Because the object is not moving in the direction of force but moving in the direction of x direction. But why it is like that? Because all force applied, see, immediately will pull means directly it will come, but slowly if you pull means it will come in the x direction. Now the question is why? Question is why? Why? Because all force whatever you are going to apply is not utilized to pull that object. Then who is going to responsible? Who is responsible for this? That is nothing but the component of force. No, the component of force is how much here? F cos theta. The component of force is how much here? That is F sin theta. So this force is utilized with the mg, or this force is balanced with the mg. Weight is balanced, and for the displacement it is necessary F cos theta. Means I can say the image of force here, the image of force here on this which is responsible for the displacement, no? So that becomes cos, that becomes scalar product, and that is nothing but F cos theta. That is nothing but F cos theta is causes the displacement, no? F cos theta is causing the displacement means in this way. So generally what is scalar product is? Scalar product if I write down here means that you don't write down, now you can write down. Okay, A vector is there. Okay, now B vector is there in this way which makes an angle theta. Now what is the image of this? That is here. So I can write down it is A cos theta. I can write down it is A sin theta. So if I multiply this, that is, this is nothing but cross dot product is nothing but the projection of one vector over the another. You can define it that way. Dot product is nothing but it is the product of magnitude of two vectors, product of magnitude of two vectors and the angle between them. Product of magnitude of two vectors and the angle between them. Now why we are doing this? Dot product means if you multiply two vectors, we are going to get a new quantity that may be vector or may not be vector. If it is a vector, we are going to call it as a cross product. If it is not vector, we are going to call it as a dot product. Then actually what is the dot product is? Dot product is nothing but this is. Okay. So here dot product is A dot B. You are going to write down A and B are multiplied means the effect of A on this is nothing but A cos theta. No? And B, the magnitude. So we can write down AB cos theta. That is nothing but A dot B. That is nothing but AB cos theta. This is how we got. That is nothing but the projection of A vector over B or image of A vector over B. So what is the contribution of A vector to the displacement? That is what it says. So A dot B is nothing but AB cos theta. A dot B is nothing but AB cos theta. So two definition we have got. So A dot one we have to write down because it is a dot product. Now AB cos theta and another we can write down A dot B is equal to AX dx plus A by by plus AZ dz. Now your question is where we are using it, what actually it is. So where we are using means definite all the areas of the physics we are using it. That application we should have to get, we have to get in our next chapters. But how did we get? What is actually called dot product means? Dot product is the image of this over the another vector. The projection of one vector over the another vector, that becomes the dot product. The projection of one vector over the another becomes a dot product, or the effect of one vector over the another becomes a dot product. Or you can you have to write down in this way actually if it is asked me for the exam. What do you mean by dot product? Dot product is nothing but the product of magnitude of two vectors and angle between them, cos of the angle between them or cosine of the angle between them. That is what you have to write down. And this is A dot B and AB cos theta and A dot B. This is the formula. Okay, this is just you should know. Okay, this is what about dot product is. Okay, little bit about dot product. So you can see the two vectors. That is nothing but one I am going to write as A vector. Okay, another one I am going to write as B vector. No. Now, what is the projection of A vector over the other? What is the image of this vector on this? What is the effect of A vector on this? That what I have to do, I have to divide this into two components. No, this becomes A sin theta, this becomes A cos theta. So this is the total effect. No, that is A cos theta and B. So it will become A cos theta. Similarly, what I have done? To find out the effect or the projection of A vector on B, what I have to do? I have to draw a line from A, tip of the line A to B. I have to draw a perpendicular. To B, it must be perpendicular because I am finding the projection of A vector on B. Now I am going to find out the projection of B vector on A. Means one line I have to draw which must be perpendicular to A. Okay, so if it is theta means this is B, no? So it becomes B cos theta and A. Okay, B cos theta. This is the right angle triangle, no? This is the right angle triangle. You can get. Okay, so how we are actually going to get it here? That is nothing but cos theta which is equal to how much? Cos theta is nothing but adjacent by hypotenuse, isn't it? So this is the thing. Adjacent is nothing but A. I can write down that is nothing but B. So liabilities. No. So this is what cross dot product is. That is nothing but what is that? Okay, that is nothing but projection of one vector over the another. Projection of one vector over the another. Now based on that we are going to define work. Now work is nothing but I said that is in the initially I said work is nothing but what? Work. We will say that we told that work means we have to read, write, having food, everything is a work, no? But in physics, what it means? According to physics, those are all those not work. According to physics, the work is nothing but if suppose an object is there and you are going to apply some force and then if it is moving me, that becomes a work. Work is nothing but it is a physical quantity for which if you are going to apply some force on the object and there is a displacement, then it's said to be a work. Work is said to be done or work is done, we are going to call it as work done. Okay, so we will say it is work or work done. Work done means there is nothing but for the applied force there must be a displacement, then work is said to be done. Now I will give again that example, that is a toy will be there, displacement will be in this direction, no? Force will be by angle theta. But what actually? All force is utilized for displacement? No. Which force is utilized? Only the component, that is nothing but F cos theta is utilized for the displacement. Now what I will do? There are two vectors. Work done is nothing but the dot product of force and displacement vector. Dot product of force and displacement vector, or force and displacement vector. X you can write down or D you can write down. Doesn't matter. So F means Fx cos theta. No. A dot B means what you have written. A B cos theta you have written. Work means so itself is same. No. Why you see work done means multiplication of force and displacement. Okay, but why that work you are going to treat it as scalar? Why you are not going to write it as a vector? Because this is the product of force and displacement only. But why you are not writing it as a vector? Because that work done does not going to obey the law of vector addition. The work done does not going to obey law of vector addition. We have discussed in motion assembly in such a way that work done is said to be okay, or any object quantity is said to be what? Vector means it must have magnitude, it must have direction, and it must obey law of vector addition. But work that is not going to obey the law of vector addition. The work is not going to obey the law of vector addition. I will give you an example in this way. See, the kid is going to apply the force in this way, that is displacement vector. Force is applied, this is F in this vector. But work is done in this direction, no? Okay, but actually, triangle of vector addition means what it should be. So, displacement and force both are in one direction, and the displacement Fx must be in this way, no? But it is not happening. Work will be happening in this direction of displacement. Okay, it is applying the force and work is done. So work done means it is not going to obey the law of vector addition. Okay, that's why work is a scalar quantity, and that is the product of force and displacement, or we will call it as a dot product. Work done is nothing but a dot product. So this is what simple example I said, and this is what we studied. What is work? Work is nothing but work done. Work is said to be done if okay, for the application of the force there is a displacement in the object, then work is said to be done. That is what work done. Okay. So next we have to find out what kind of works are there, what are all the things that we are going to talk about in the next class. Okay, thank you.
Don't forget to like our video and subscribe our YouTube channel for all the updates.